Religiously? I'd have to have time, though.
People in my brain are like scraping off the rust of my brain right now. They're like, oh, can't get this wrong.
All right, you guys have been able to work on this for a little bit, so let's see.
She'd be like, let's take a look at Michael.
Don't know how this is going to turn out. Let's see. Let's see. I don't know. I can't read it. Let's see. All right. I was able to tell a few of you guys. All right, quiet on down. We'll make plans about me being a vlogger later. Yeah. Okay. As you guys are taking derivatives, I want you to see if this makes sense. I explained it to one person. I think it makes sense. How do you take the derivative of x cubed? 3x squared. Couldn't I say times x prime? Is that legal? Isn't that just an application of chain rule? Derivative of the outside, 3x squared, times derivative of the inside. What's inside? X. Who's x prime? 1. Oh. Plus, what's the derivative of y cubed? 3y squared times y prime. And when I go on the other side, and I take the derivative, second, y squared, d first, 3 times x prime, plus 3x, derivative of y squared is 2y times y prime. But do we ever write x prime? No. Why? What is the derivative of x prime? Yeah, it's technically dx dx, and dx dx just reduces to be 1. The derivative of x with respect to x is just 1. So therefore, most of you would have just written 3x squared, and you're totally right. But the problem is, what's the derivative of y prime? Derivative of y with respect to x is dy dx. Do you guys see why the dy dx stays, but the x prime doesn't? We don't write the x prime because it's always 1. What's the big deal? So whenever you take the derivative of an expression with the variable matching what you're taking the derivative in terms of, we never have to write that little chain rule step because it's always 1. But we could write it and then just make it 1 every time. And then we'd be doing the exact same thing for every single expression. But this one, once again, x prime is just 1. This one, though, y prime is dy dx. Now, if you were able to get there, now we have to think about simplifying to get the derivative alone, but we'll do that after Ryan's question.
Okay. Why can you just write dy over dx times, do you have to distribute that?
No, because it's all multiplication. It's all multiplication. Like if we were to say 2x times y, we just say that's 2xy. There's no distribution because there's no addition or subtraction. So multiplication can either be written next to each other or can have the raised dot or can have parentheses, but it all means the same thing of just multiply, multiply, multiply.
So dy dx still goes to both 3x squared and 3y squared?
No. Because this only came in taking the derivative of this piece. Remember the sum and difference rule? We take the derivative piece by piece. And so this one had an x prime, which is just 1. This one, this piece only needed a y prime. Because the dy dx had nothing to do with taking the derivative of x cubed. Dy dx, remember, is just the derivative of y. Technically, it's 1 dy dx. We could also say y prime. Does that make sense? So I just substituted the y prime for the dy dx, and it's just being multiplied, and so it gets absorbed in that one term. But without parentheses, there's no distribution. It didn't come about. It wasn't a part of this derivative at all, so it's not even going to go in there. There's no distribution. And same thing over here. Like when we take the derivative of 3xy squared, the 3 goes with the y squared. It doesn't get distributed across the addition. There's no multiplication that's supposed to happen when you take any sum or difference. Now we could factor a 3 out. If we factor a 3 out, then it should be distributed back in. But the 3 just distributing across the plus. Right, and I think you're just trying to do something illegal. And somehow you're trying to tie this term together with that term, and there is an addition, but there should be no multiplication. There should be no multiplication. So as we rewrite this, I'm going to rewrite this as 3y squared dy dx minus 6xy dy dx equals negative 3x squared. What did I just do? Try to get like terms together. Now, wait, these aren't like terms though, right? So why are we calling these like terms? They're not technically like terms, but what is similar? What is alike? Both of these have dy dx's, and both of these don't, right? So some terms, when you're deriving implicitly, remember is the name for it, some terms are going to have dy dx's because y expressions had to be derived. So y primes had to be included. Y expressions had to be, triangle prime had to be derived. So y primes or dy dx's had to be included. But not all of these terms needed y prime. Not all of these terms were taking derivatives of y expressions. So the ones without dy dx's just get subtracted to this side, to the right. Ones with dy dx's get brought to the left, not because of any magical having them on the right, having them on the left. What do we want to get alone eventually? Yeah, eventually we want to get f prime of x, or in this case our notation, dy dx, alone. So how do we get it alone? Can't really combine, but what we can do is factor. And in a sense, when you factor out the dy dx, you are combining the coefficients of both of those. We just can't get them put together anymore. We just can't get them put together anymore. And once we factor out the dy dx, what was the purpose of that? What can we do now? Find the derivative, aka get dy dx alone. Express the derivative is what I would say, since we've already been finding it along. But express the derivative by dividing. I think Patricia, that was you, yeah? I lost a negative, didn't I? Is that what you saw? Thanks. What did I just do? Factored out a 3, and then reduced 2 3's. But I kept my signs the same, negative x squared, positive y squared, pulled out a 3, y squared, pulled out a 3, minus 2xy. Do you guys see why this would be just as accurate as the one above as far as representing? What if I was to do x squared minus y squared all over I think they would leave that in. I was trying to think of what they would do. I think they would leave it in. They could have factored out a y, but I think they would have left it in. Do you see how they're both exactly the same? Okay, they're not, but how are they both equivalent? How do you flip the signs, ever? Couldn't you pull out a negative 1? And if you pulled out a negative 1, the signs would flip, but what would you need to do somewhere else to get rid of that negative 1? Pull out a negative 1 on bottom, too. So you could pull out a negative 1 on top, pull out a negative 1 on bottom, which is why their signs flipped also. And if you guys ever saw something that was so similar, but the signs were all messed up, you can always do this little trick to your answer and be like, I wonder what would happen if his signs flipped. You could always take your answer and say, what would happen if the signs flipped? Oh, hey, it does match up. Sweet, I like their answer. Why could they have done that? The AP doesn't usually like leading with a negative if they can help it. So it's one of those random. Sometimes all the signs get flipped, but there still would be equivalent. So this might be your answer, and that might be the make it match. Anyway, What's this whole process called where we have to take the derivative of both sides because the x's and y's are all mixed up in an expression? Implicit differentiation. We have to derive implicitly, aka take the derivative of the mess, take the derivative of both sides, and don't forget your chain rule. That's ultimately the mistake you're making if you don't put a y prime. You don't have to write the x prime because it's just 1. And so we know the derivative of x cubed is 3x squared if we're doing d dx. But it is good maybe for some of you guys to see why the y prime is there and why it remains, whereas the x prime goes away. I've been trying to see if there's a new HCTV. Sorry, guys, I don't know. Oh, that's great. That's even worse than it was before. They might be trying to load it, and that might be what's going on. So I might try one more time during class to see if we can play it, just in case there's some announcements. I know that today is chapel day. I think tomorrow, is tomorrow the Thai tea fundraiser, or is that Friday? Huh? So Friday. I'm sure there's a brache bread something going on tomorrow or Friday. I don't specifically know any other huge announcements besides that, besides welcome back from retreat or welcome back from Venus Lacquer and having 2 free days. But don't worry, we love you too. All right, let's go ahead and, it's killing me a little bit. Hold on. There we go. Let's go ahead and go back to our notes. We're going to do some more examples today. Homework is due tomorrow. Ryan Voda also already asked about the extra credit sweatshirt ideas. Some of you guys just lost track of that and didn't think to check Google Classroom to make sure that everything was good. So there is that extra credit opportunity of posting ideas. I will go ahead and give you grace until midnight tonight for those ideas if you have any. Do they need to be in like their super polished, send to the t-shirt person tomorrow form? Not necessarily. Our t-shirt guy is pretty good. And if we decide that we like an idea, he can usually kind of make it, even if we don't totally have it solid yet. But it does need to be like actually somehow expressed in a picture form for me to be able to compile and then put together like a vote for the top 3 or whatever that you like, and then we can hash it out in class after that. Sound good? Okay. So I'll give you until tonight. That's okay. If you guys start falling asleep, I know it's been a rough couple days for some of us. The coffee is still warm. The donut holes, there's still plenty. It's better to go grab something than to fall asleep. Otherwise, as you guys are writing, anything else going on today? Did I hear there's a Bible test? Is that you guys? Oh, it's on Friday. Huh? Oh, I'm sorry.
We had English homework that haven't even talked about. We had English homework that was weird.
Not a lot. Like one line. One line should be good. $2,000?
I spent all my
I was like, oh my goodness.
I
get like 300 points a day.
Justin calculated mine at 7.
Patricia sits in class and reads the book and gets points.
100 points.
And I call him Mr. Jones Versatile and give him like 3 points.
He does it like
But you get 3.
a day, and then he gets 9 points a day.
Michael, maybe you should start reading your book.
Ryan fell out of his chair one time and he got 10 points.
Those are pity points. Those are pity points.
I racked up a bunch at the beginning of the
And then
year, but
everyone
I
else started
noticed
falling
that
out of the chairs.
I
Everyone got 10 points.
What? They just get louder every time I ask you what.
Mr. Jones Versatile, that's 9 points right there.
Yeah, I didn't fall out of the chair, that's 19 points right there.
Your name is Issa? Another 10 points right there.
All right, guys, grab out your reflections when you're done. Remember, you had the weekend to finish your Sudokus if you didn't know how to play before. Sudoku.
You just gotta write a thank you letter to what's his name.
Come on, screen. Come on, screen. Come on, screen. Maybe, maybe not. Where's the optimism? But now need to apply it to harder problems. What was I talking about? I'm talking about whenever we had something back in the day where we were supposed to find the derivative or find dy dx. And I gave you something like, I don't know, y equals 5x squared. How easy is this? Super easy, but technically, what were you doing when you got to the answer? You were taking the derivative of both sides. When you took the derivative of both sides, the derivative of y is what? dy dx. And the derivative technically 1 dy dx, but either way. And what's the derivative of x squared? 10x times prime. Do we ever write that part? No, we just said 10x. So were we kind of shortcutting even when we did our shortcuts? Yes, and we can't always do that shortcut because it's not always legal. Just to say, oh, on one side, dy dx. On the other side, quick power rule. Dun, 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 dun. Ah, it's a little bit harder than that, but you guys know from your opener in the back of your homework spiral. Real quick note just about differentiability, continuity. We talked about that earlier this year. A function is not differentiable when it, meaning the function, is not continuous, or when a tangent line would be vertical, or tangent slopes don't agree. AKA, vertical tangent line, or a sharp point, or a lack of continuity to begin with. We already did that example. How about this guy? Let's do it all together. I'm not going to leave you guys stranded. But just a few of you might be like, ha ha ha, I got it. I'm going to zoom ahead. So I'm giving you like 30 seconds to write down the problem. And for those of you that do want to zoom ahead, go ahead. For the rest of you guys, I got you. Let's just give them a couple seconds to get ahead. Zoom. It's a little too warm. It's a little too like, I want to take a nap right now warm. Just let me open the door. Get some airflow going. All right, some of you have zoomed ahead. For the rest of you guys, slow and steady might win your race. Okay. So we're not racing each other. Not right now, right? Okay. d dx, both sides. I need to find the derivative. Just in case, chain rule notation does help. You could do that on the left-hand side. What's the derivative of cosine of u, guys? Negative sine of u times u prime. Oh, how do I do u prime? Right? Does your brain read the times and think product? Good. Second, haha, rewrite. D first. Plus, now hold on. Ryan, remember how we were talking about the whole distribution craziness? Why am I needing, as soon as I write this plus, to come put a parenthesis? Why is that important? This guy does have to distribute. And I don't want you to get confused. Why does he need to distribute? I need f prime of u times u prime and times the entire u prime. So the entire u prime is the product rule, and the product rule has two different pieces being added. So it's not that I'm like treating a multiplication one way 1 second and one way the other, but this negative sign of u needs to get multiplied by the entire sum because it's f prime of u times u prime. And so here's my f prime u. And since he needs to be times u prime, I need him times the entire u prime. Does that kind of make sense? Good. Good, good, good. So I have second d first plus first d second. You guys get 2y times y prime. Or dy dx. Good. But that's only one side of the equation. What's on the other side of the equation? Dy dx. We cannot forget both sides of the equation. For so long as you guys were just getting fast at the basic rules, you were only really worried about one side of the equation. You can't do that now. All right. Why am I going to do this? First of all, who's you? Okay, so you get that plugged in. Why am I writing a y squared in front of that? I'm distributing. And why am I distributing? There's no other legal way to go about getting dy dx alone if you don't undo the multiplication. I need to get terms just added and subtracted so that I can move them wherever I want them to go. So even though you might not like it, this negative sign of u does have to be distributed to both terms because I need this dy dx term to get to that one. And the only way to properly do that, not division, is get that multiplication undone. Now I just have terms added and subtracted to where I can go ahead and just move them around. So even though, guys, in your notes, didn't I say always get dy dx to the left? Why am I going to move it to the right? Is it mathematically legal to move it to the right? Yeah, totally. Yeah, and I kind of like the whole, like, hey, let's just make it all positive down there. Could I have gone the other direction? Yes. What would have changed? All the signs would be opposite. If I had subtracted and if I had added, the signs would be opposite. So that's why I'm saying you have to kind of keep an eye open, because maybe you have the right answer, but your signs are opposite because you moved it a different direction than they did. Can anyone get down to the final answer with me without doing any other work? How'd I get there? You guys saw it, right? I factored out. When I divide, there's a 1 left to hold the place. Does that make sense? Sorry, squared. It's so easy to lose a squared somewhere. It's so easy. And maybe the multiple choice answer will have one without a squared, banking on the fact that you'll lose a squared. So mean. So mean. Just be careful, you got everything. But did you guys match up with mine? Cool. Yeah, AJ, I'd say box it. And I think I like my form better than the other. If we had moved to the left, that would be a positive and these would be negatives. Ugh, that's kind of gross. AJ. Why did I write that in front? Because if I write it down here, it gets confusing as to what's in the sign and what's not. Technically true, but the multiple choice won't show that because of alphabetical order every time. Does that make sense? Yeah. Okay, what else we got? Oh no! What if they say find the slope? Oh, they just mean find the derivative at. What does that mean? Plug it in, plug it in. As soon as they give us a location, we have to make it specific. If they ask for it, I suppose. Yeah, but look at this guy. He's an easy derivative, isn't he? Okay, get down the question. X squared plus 4y squared equals 4. The point is root 2, comma, negative 1 over root 2. Remember, things don't have to be rationalized in calc. Ain't nobody got time. As you guys are writing the problem, I'm just going to do d dx on both sides, right? Careful the mental math. We have to take the derivative of both sides to make it legal. The 2x is pretty easy. The 8y dy dx is hopefully pretty easy, but would you have remembered to do 0 on the other side if you hadn't written d dx? Remember, the derivative of any constant, yeah, is 4. It's really easy to forget that, though. dy dx is equal to, what, negative 2x over 8y? Negative x over 4y? What do you guys think? But that's not the answer. What do we still have to do? Oh no, we need an x and a y. Oh, hey, they gave us an x and a y. Wait, what if they only gave you an x? It would have been impossible. Or we would have gone and plugged in the x way back here and found the y and then plugged in. Just because it's implicitly defined doesn't mean that you can't still plug in an x and find a y. Anyway, they did give us an x and a y, so therefore we can say the slope at the point is what? Negative root 2 all over 4 times negative 1 over root 2. If this was a long answer, what should you do? Box it and be done. But if it's a multiple choice, it's a complex fraction, right, cool kids? Couldn't we have multiplied by a root 2 over root 2? Those would have simplified. Hey, a negative over a negative is a positive, and then a root 2 times a root 2 is a root 4, which is a 2. And a 2 over 4 is a, oh, that's really just 1/2? Oops. Anyway. Could they ask you for a tangent line given an implicit function? Yeah, sure. If you can find a tangent line. Can they ask you for when the when the tangent lines are horizontal? Sure, if they want to. But here's the dilemma. What if I think we have one more minute. Oh no. What if they say find the second derivative? You have to do it again. Oh, that's no big deal, guys. I'm going quick. So 3x squared plus 3y squared dy dx is equal to 0, which leads me to dy dx is equal to negative x squared over y squared. Okay, does that make sense? So what's so much different? Why do I have this big old page about the second derivative? No big deal, go again. Okay, but when you go again? First of all, remember your nasty notation. You are going to have that funny d squared y over dx squared. Just means the second derivative. But when you do bottom, d top, minus top, d bottom, uh-oh. What do you have in the second derivative all of a sudden? I'm not done until I have it in terms of x's and y's. Whatever am I going to do? Who was dy dx? Oh, I know who he is. So what are you going to do to finish the second derivative? Go back, get dy dx, and plug him in, plug him in. And when you plug him in, you might have a complex fraction you have to simplify, but didn't we just look at that and say, no big deal, we can simplify complex fractions? Just don't forget, when you simplify, when you multiply top and bottom by that y squared, don't forget that y squared is going to need to distribute for the top and the bottom, or else you're going to make a mistake. Kiddos, thanks for the extra 60 seconds. I do appreciate it. Just don't forget, when you're simplifying that complex fraction, to go carefully. All right, cool kids. Get out of here. I'll see you later. Do the best you can for the homework for tomorrow. If you get a little stuck on second derivatives, just get as far as you can, and then post a comment about where you got stuck. Or show the questions in your homework.